So thanks for the introduction and thanks for the invitation, Vijay and Rahul. I appreciate it. Also Christian from Erhard and Abt, our dear system partner. So the title is currently Intelligent Robotics, but I figured that robotics is at least a part of your deal at Vijay Technologies, but not the only deal. And so I'd like to skip the focus a little bit away from robotics into the general aspect of Industry 4.0 and how that mystic technology will enhance the current technologies that are evolving and how you can actually use it today. And I'll try to catch up some phrases from Mr. Hanke to show you how reality already is working with data and how, let's say, that call for action that I'll give you is very current. So with that, again, thanks for the introduction. As mentioned, I am from Cukor and I'm running the program for Industry 4.0 across the group. And just to give you a brief introduction of what I thought that slide was out there, so introduce myself. So, what is Cukor actually doing? I hope you've seen some of the orange robots, and I've seen one of those inside of your assembly hall. So we are doing robots. Robots is basically 6x kinematics. It's like an arm, but it's pure movement. So aside of a tool at the top, it's really only movement. So now to make that movement valuable and grasp or get that flexibility of movement into the process, we utilize system integrators. System integrators like Erhard and Abt. They buy our robot and they buy or construct a tool. Like, for example, I saw the C flange with the X-ray in between. And now all of a sudden, that movement, that flexible movement gets a real flexible process. And now with the process, you solve a problem. Now, Cukor, as mentioned, is selling components, robots. But we also do systems. So we do have a Cukor Industries facility that are mainly focusing on welding applications. And we do have our Cukor Systems that is making approximately 1.4 billion that is mainly focusing on body-in-white automotive lines. So whenever you have a whole bunch of automotive parts and you throw them into a black box, and out of the black box you get a body-in-white, this black box is done by Cukor Systems. And very importantly, Cukor Systems is the biggest robot integrator for FANUC robots in North America. So there's Cukor on top, but FANUC inside, which the robot guys don't really appreciate, but it's inside, it's a business, right? So the end customer decides which is the most valuable robot to them, and the system integrators takes that robot and basically brings that process up and running. Now, there's a lot of, I told you about all throwing the parts into the black box, and then there has to be some sort of order, right? So there's process 1, process B, and there's a lot of intralogistics. So Cukor recently, well, it's now already 3 years ago, I think, we bought or acquired Swisslog. Swisslog is a pure logistics company. They're very much into warehouse automation. And so now we basically see that we complete the entire picture of a production line, right? So we bring the most of flexibility with the movement, with the components. We do integrate them into whole systems, and we can connect the process steps in between. So basically, come into Cukor, you get automation. Now, Industry 4.0, what do we demand? There's a next level, there's IT. Now, those guys know about IT a little bit, but they're mainly focusing OT, right? So operation technology. Now, Cukor has founded inside of Cukor a company that's called Conyun. Connectivity, and Yun is Chinese for cloud, so connected cloud. Very, very smart wording. So that Conyun company is pure IT focus. What we do is we create cloud software architectures. Conyun is building a cloud platform. And now we see that this cloud platform perfectly adds up to the automation business that we provide today, right? Because now we are future ready by having our own platform, our own analytics tools, and our own data streams to evaluate how the processes are actually running. Now this entire construct is basically under the holding Cukor AG, and within the holding there's this accelerator team for Industry 4.0, and there I'm located. Why is it a holding topic? Because everybody of those 4, let's say, themes or topics is having a different idea of Industry 4.0, right? So, who has heard of Industry 4.0 in this room? Now, come on, little action. Who knows what Industry 4.0 is? Be brave. I'm sure if I would ask you, everybody would have an answer, right? So the same do those guys. The robot guy says, yeah, it's all about asset management. Woohoo! This guy is saying, well, no. We have to see the entire value chain of production. We have to get the supply chain in. And the Swisslog guys, they're saying, well, I need to know every single step of my product. Whereas the robot guy says, no, I'm still asset service. And now what we need to make sure is that all of those visions fit into the same idea of digitization of Industry 4.0. So we have to bring them together, align them, so we go on in the same direction of future. This is my current role. So, coming back to where we're actually heading, digitization. And I'm sure everybody is aware that it's affecting all of us, right? If I was wearing my smartwatch, that would be even better, because then I'd have the proof right at my wrist. Digitization, everybody has a smartphone, everybody's typing into notebooks, taking pictures. We are creating tons of data every single day. Now, we have privacy laws. The robots don't, but we're basically making ourselves very transparent, whereas the robots currently aren't. So now I'm focusing on robots because I know those examples very well. Same goes for technologies from VJX, for example. Now, how much transparency do you have from anywhere around the world about your technologies out in the market? And this is basically where we try to transfer the digitization aspects of private environments into the production facilities. And how do we do that? Now, if I asked you, right, so what is your idea? Now, this would be the greatest. Hey, we have a button, and if I press that button, my component, my service, my anything is Industry 4.0 ready. I'm so good to go because it's just there. But what are the ingredients of Industry 4.0 ready? We have different ideas, I'm sure. So mainly it's all about data-driven. So we have to get data out of everywhere. Professor Hanke just mentioned that. Get everything or get just the right parts. But in the end, it's about data. Because with data, we can do data analytics. Whatever that means, but everybody knows, yeah, data analytics is very important. And now data analytics drives us to digital twin. Yeah, with a digital twin, I know what the future will be in my production facility, I know where my product is, and then at some point, that future or that simulated reality will be more sharp than the actual reality. Is that picture, right? And then if we go into the production sites, that helmet is that's just cool, that's just because it's very fancy, but all you do is work on tablets. Also vision, we've heard so many times. And the idea in the end is today I configure my shoe, and tomorrow I get it. Well, currently there's 6 weeks in between because the configuration is held online, but then the production is somewhere in Asian markets, for example. Now, how do we combine that vision with all of those aspects in order to get that idea? Well, there's different ways of approaching that. Very certain, I heard it from Professor Hanke too, is that we have to, by the way, I'm sorry about the color code, it's actually more orange than green and blue, but I think it got a little mixed up. Anyhow, so that's why I might be a little confused in here and there. So, Professor Hanke mentioned, data is very important. Now, cognitive sensors might send data. Those data will be collected, but unless we interpret them, they're just data. That's big data. Now we interpret the data and see, all right, I got variable A, variable B. We bring a little bit in transparency in there. We know that it's not only data, it's not zeros and ones, it's information. Once I gather the information, I also need to interpret that. And then I get to knowledge. I know what kind of correlations we have, what the robot sends, what the machine, what's the X-ray sensor sends. And then I have to create wisdom out of that because now I judge, well, if I put a little bit on variable B, then variable D will change. Then I create wisdom. And with that wisdom, I can actually take decisions. Decisions based on data. And this is what you just mentioned. It's about parameterizing. It's about pre-configuring. It's all about that self-learning aspect. Now, those steps are very mandatory to take to enable a machine to take a decision. You could take a decision anywhere here. You can collect data and take a decision, that's fine. But until you get a machine to take founded decisions, you need, or we think, you need to run through that evolution, right? Now, where are we currently at? Because in private world, there's plenty of data. Anybody using Google Maps, you know it. There's so much information in there, right? So how about my production facility? How much information do we really have? And I'm looking at Christian. Obviously, our cell and the robot is communicating with the PLC, and the PLC is communicating with the light sensors, and so on. But the communication currently established is the robot says, I'm done. Then the other machine says, okay, I go. Then the robot says, are you done? Yes. This is the information we're currently transferring or communicating. Now, the future would be the robot says, hey, I'm feeling great. My oil temperature is really good, but my ventilation system, hey, you might have a look at that. This is currently only in the robot control. Nobody's taking care of that, currently. And now we're basically moving from data collection to information where we take different data that we have already established in the system, take it out of there and analyze it. And on top of that, we build services. Services like classic asset management for the robots. Now, any questions to that? Does that make sense? Good, that's exciting. Good, at least it makes sense. If you have questions, please challenge me, because that's the way we learn, right? So in case doubts, approvals, you go. So now we see the theoretical part of taking decisions. There you go.
You're talking about unsupervised learning.
In this particular case, it would be machine or decisions taken by machines based on data analytics. This is what we see, that there is a mandatory evolution of looking into data.
Supervised learning.
Supervising.
Well, learning can be supervised or unsupervised. Is the machine learning by itself? Or
So you're going even the next step. So this one is very basic. But obviously, creating wisdom would be machine learning. So in order to make the decisions better and better, we have to create a data knowledge base. Somewhat, it might be, I only know the German term, the neuronal systems. So, thank you. So that might be inside of wisdom, yes. But in the very beginning, we're talking about, it doesn't have to be machine learning at the end, it's just enable a machine to know which parameters you know or you need to do for this X-ray process. This would be the very basic. Now, decisions, check. But what are we doing that for? So I asked you Industry 4.0, but what are you doing that for? Why? Well, there's digitization, there's a dark future of data, and Google will take us all over, and no, it's not that. It's very simple. Digitization in Industry 4.0 is an additional vehicle to increase your KPIs in the production and your process. It is all about uptime, right? So the car manufacturers, they tell us, hey, Cukor, your robot falls down, that costs me one body and wide a day. That is very expensive. So they want the uptime to increase. They want to be assured that the uptime is at above 99%. Now, how can we assure that? Until we monitor and track the data, we have an idea, but we don't have an idea over our entire installed base. So it's about uptime. It's about quality. What about quality? And Professor Hanke mentioned it also. What is the data that you get at the very beginning of the process, and you might need to interpret the value of the data at the very end of the process, right? Assembly. It's all about the Toleranzen, the tolerances. Good, that was an easy one. So it's all about the tolerances, and you need to keep them, right? Otherwise, the quality gate at the very end says, sorry. Well, when at the process can you stop off that value chain in order to say, all right, I save at least the rest of the time? Then you go for flexibility. On the one day you want to produce washing machines, and the other day you want to produce cars. Yep, we do have concepts like that. It's called Matrix Rohbau, basically matrix production. You only have cells, and the cells get equipped by an autonomous guided vehicle, an AGV, and the actual part comes also by an AGV. So this is basically the highest flexibility you get, which is not counting for the current established production of cars, because they are just focusing on output, 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 output. But when you need flexibility, you need an additional door next Tuesday because you didn't produce it. Well, then this kind of matrix production might be of value. For that, you need recipes to program into the system. You need intralogistics connectivity, the basic of digitization. Cycle time goes down. You need to be faster. And this is where you need to look into processes. Now, do we know how much worth data is? So if I ask Christian from Erhard and Abdin, he says, yeah, I built a cell right there. And if you could get me all the data I need, I could save you 20% cycle time. This is very, yeah, I wouldn't say that's the way going forward. We need to learn how much worth data of processes actually is. Because only then we can continue and evaluate, as Professor Hanke says, well, I don't need 150 pictures, I only need 7, because I already grasped the right position of the C flange. Flange? Yeah. So this is, I think the examples are clear. Inventory down as far as this goes, because or just production in time, just in time production, that's the English word, sorry. So just in time production, ramp up time. So how fast can I get my line up to 100% of output? Just to give you an example, for cars, it's about 5 to 6 months until they want to ramp up to the SOP. Now, for electronic devices like cell phones, what do you guess is the time? Come on.
10 days?
10 days, that's pretty close. It's 96 hours. So how do they do that? Well, at night, they call their workers and say, well, the next day you have to be here and you have to work. Then hundreds of thousands of workers go into the production and they assemble cell phones. This is the current only way of how you can do that, because the ramp-up time of basically configuring your line, of programming the robots, of programming the processes like screwing, that takes time. We need to ease that, or make that easier and easier, and when we talked about that yesterday, it is all about the usability of the products. Now, this is an additional way of pre-configuring offline programming and then deploying it to the system. This is a way of increasing or decreasing, in this particular case, the ramp-up time. Therefore, Industry 4.0 are not for the sake of digitization because it's a megatrend, but there's actual value behind that. It's the KPIs that you already considered today, but now you have a different tool to approach them. Now, enough of the theory, let's have a look into how... That's interesting colors again. Now let's have a look at how we interpret that way, right? So what we have at the very bottom is the hardware. What you see in your assembly line, you see the robots, yellow, orange, doesn't matter. You see what's on there, you can touch it, you can shake it, whatever. That's the hardware. Now all those are currently communicating amongst each other. They're saying, I'm ready, you go, I go. That process is set up. Now we add a different level. That's the edge level. That is the last actual hardware piece that combines all of the data from the manufacturing components and builds the bridge or the edge to the IT world. So as you go home, you might have a Wi-Fi router, and you're connected to that Wi-Fi router with your cell phone, with your tablet, with your notebook, etc. The same right here, right? Everything is connected to one gateway, and that gateway is building the bridge to the IT world. Now the data is being sent to an IIoT middleware, so Industrial Internet of Things middleware. And this is where the magic can happen because it's where the power of computing lies. This is however many data you want to evaluate, this is where it can happen. It can happen down here, but you're limited, or you have to build up your own IT infrastructure. That's possible. But what you want to go for is the big goals. You want to collect so much data in order to actually get that machine learning going. But machine learning is not possible down here, so you have to build the bridge. Now, once you have the data in the cloud or in your IT infrastructure, you want to access them, right? And the best way of doing that would be by your cell phone, smartwatch, notebook, whatever. So that's the user interface at the very top. Now, again, theory, and this is how we do that in reality. We do component integration. And now I'm talking about the very left column, that's Cukor Robotics. Cukor Robotics is a component manufacturer. So we tell them, hey, there's a potential of using data to enhance the services you have for your robot. They say, cool, what do I got to do? They take the robot and let it communicate to that edge. The edge builds the bridge into the cloud of, and I'm sorry, that was the picture, of, in this particular case, Conyun. And in the cloud, the data is processed, evaluated, analyzed, and then the results are monitored onto my cell phone. And I can see from the robot I'm standing in front, okay, it's moving. it's not the most valuable information I get, but this is only the first step. It's the proof. What we already have is a monitoring of the oil temperature. This is why I took that example earlier. We have a movement or an analysis of the degree per axis, and we can track how the robot is actually used. If the end customer where that robot is located at approves, right? So we can access data that is owned by the end user. And the same goes for technologies from VJ, for example. Now, what kind of data would be of value that you bring into the cloud in order to add services that enhance the KPIs of the end user with your components? And this is basically the call for action that I would like to put here. It is available today to utilize technologies of cloud infrastructures to bring services out of that digital environment into your production facilities and to your components. Now, the value of that data for your components is just interpreted by you guys yourself. We can't judge, but we can just give you the idea that it's already working. And we have ideas of how our robot gets more likely chosen aside of a FANUC because we have a great additional services through the digitization world. And one of that end service, very visionary, where we could be looking at, is robot or movement as a service. Now, every pick and place item will be paid by that end user. Now, the benefit for the end user, he doesn't have to go into big CapEx, but he runs that facility with OpEx. This is just an additional benefit that we could get. For us as a robot supplier, it's an entirely different business. All of a sudden, we are the bank for movement, right? Because we're not selling components, we're selling movement. This is an entirely different business, and this has to be considered by our company itself. Now, let's look into Champions League. This is Champions League process integration. We want to monitor how that arc welding seam is being done. So an inline quality gate, so to say. What kind of data do we need to consider in order to give an okay or not okay at the end of every single line or seam that we have welded? We need the robot movement, we need the, now I'm sorry, I'm missing the words, the electricity out of the welding controller, and now we already have two components. One is the robot controller and one is the welding controller. And then the torch at the very beginning, at the very front, should also say, is it okay or is it wobbling, the thing that comes out of there? Now we have a third component. So we need to integrate or communicate with all three items at the same time into the same cloud, into the same data analytics. Now, how do we do that? I'm looking into the system integrators again. They know the process. They know the value or the parameters they need to change in order to bring that seam to the next level of quality. Now, again, this is a task or a challenge of how can I add a digital service to my already established current process setup. And we're looking very much into brownfield applications, so old controls, old PLCs, and everything around that. So this is very challenging, but very, very, let's say, current challenge. So, questions to the process integration? Good. Now, call for action. Well, what is your asset you would connect to a cloud? And what is the service that you would run onto any platform? And now and this is very, obviously we run our own platform. I just talked to a GE guy, GE Predix, that's basically the same thing. Siemens MindSphere, again another platform. Fraunhofer Fort Knox, another platform. So there's so many platforms coming out of they're growing. You should consider which one fits your requirements the most. What I want to put out here is that there's no, we'll talk about that in the future when those platforms are ready. They are ready, they are available, you can get the access to it. So the question is more, which kind of service do I need to develop to serve my customer the better way? It's a very service design approach. Now, when I talk about ecosystem, or I think it was on the slide, the manufacturing ecosystem. Now, in order to bring that entire run that I just mentioned together, what do you need? You need a platform, obviously. right? So this is what Cukor interprets as the ecosystem that you need to fulfill digital services. You need a platform. At the very beginning, you need somewhere the calculating power, the analytics power. And then you need to connect all components of the process to that same platform. Then at least you have the data together. Then you need to create from data information, then you need to create knowledge, then you need to create wisdom. To do so, you might need some IIoT application specialists. Those would be IT specialists at the very ease. Now those guys might not have the idea about a welding seam, but they have a very good idea of how to write mathematical algorithms to predict the okay or not okay of each seam. Now once you have those seams, you go to the end customer. The end customer says, I have, what? A platform in my facility? I need to put something out on the internet? Oh, no, no, no. Well, in that particular case, it's a little bit about consulting. Right? If you want to get the additional service, you have to consider the external communication from your production facility. Once they're convinced, then you need to bring all those components into the production facility, and here we go again. Erhard and Up, for example, as a system integrator, they need to connect not only the process itself and build the welding seam, but then they have to integrate an edge, they have to utilize the IoT applications, and they have to promote that to the end customer with a business model. So what is the part? Every single one of those is participating in their business model. How? Well, it's very, very, very individually constructed. And this is, again, something where you need to consider what is the service, what is the business case behind it, what are the data that I need, and what are the partners that I need. And in the end, obviously, not to forget the next generation, Professor Hanke, I hope you agree, we need education to also focus on that, right? Not everything has to make money at the first beginning. We have to consider also try something new. Now, I think I'm running out of time, so I'll say this is how we move forward. We connected our assets. We're connecting an ecosystem. We are looking into data for processes. And on top of that, we are building new business models for each and every single one of those participants of the process. How do we start? We have a little consulting package where you say, well, this would be some presentation like this, a little more into detail, looking into data structures that are already existing, et cetera, et cetera. And we have a little starter kit, and we think trainings are very valuable, so we do trainings as well. Now, this is how we want to get people just to get familiar with the new possibilities. And in the end, it sums up to be a big part, or being a part of a big ecosystem can give you a different market position. And this picture can tell you a lot about how do we work together in the future. Digitization is an aspect of where we need to partner very strongly in order to get the full value out of that possibility. And I think with that, I thank you very much for listening. And if there are any questions, feel free to ask.